Okay, let's start. Okay, so we'll look at some other aspects of internet, and those who have already know it, those who are in fourth year, please be attentive also, because many things you still may not know. Okay, go through this cartoon. So we are talking about IP packet. What is so unique about IP packet? There is header, which is a metadata and data, like your mother's box of laddu. What does it contain? Both will contain what? Source address. Source address is what? Your mother's name and address, and destination. Destination address is more important. Okay, without destination address, your name and address, and data. Data here could be anything. In physical box or courier guy, she hands it over to, inside could be anything. Some sweet or whatever. The model is very similar, the way post office works and the way IP works. Okay, all right. Does it mean that nobody, see, your mother is sending this laddu box to you, she knows your address. So anybody who knows your address can also send similar box. She is sending, of course, some sweets to you, but somebody, your enemy, can also put a bomb here and send you. Is it possible? Yeah, it is possible. This is a security scenario, right? So here you can have any destination address. Packet, who is making packet? IP packet, your machine is making it, and its control is in your hand. You can always write a software to generate packet according to your wish. You can have any destination address. It could be president of USA also. IP address corresponding to US president. And source address correspond to your anybody's, not necessarily your machine source address. And inside could be anything, a malware. Anybody can send this, right? This free world. Okay, so what I've told you is nothing but a security scenario. Okay, all right. So now what is most important in any communication, any packet, is that address has to be unique. If address is not unique, your packet will not reach. Now address has also some semantics built into it, some meaning built into it. Okay. So when somebody writes your name and say hostel, whatever hostel you are into.
Hello, sir.
Hello.
Yes, sir. Some of my friends cannot join the meeting. Can you please let them?
Of course, I have logged the meeting, so ask them not to attend. If they are not disciplined enough to come to the meeting on time, then let them miss the class. Okay, all right. So address has to be unique. Okay, so now this is in IPv4, we have 32-bit address, right? We write it in this way. So this address has always got to be unique. That's very important thing. Okay, similarly, destination address has to be unique. Source address, destination address, both have got to be unique. So destination address is more important, otherwise packet will never reach. Okay, based on this, and it has some semantics. Similarly, IP address has semantics. IP address of, in general, of Airtel in Bangalore has to be, that has to be evident from these 32 bits. Okay, and based on that, based on built how IP address is assigned to you, for example, IP address to in New York to a machine connected to Verizon or whatever would be different from IP address that's assigned to your machine in Bangalore or my machine in Bangalore. And there is a location based, some information is there such that routing of packets can happen. Okay. All right. So source destination address both are of 32 bits in IPv4, and in IPv6 version 6 it is 4 times this, 64 into 2, 128 bits. Okay, and there are other fields which we'll study later. Okay, little bit about access networks. See, all of us at the end, whether you are in office or at home or somewhere else or on the way you are walking, all of are connected to access networks. I will just quickly go through it, and then please then refer book to read more about it. So it could be your mobile network. When you're walking around in the campus or elsewhere, then your mobile is connected through a tower. Okay, there we have antenna. Okay, all right, cellular tower, and you see that there is a something called cell corresponding to a antenna. There is a cell, and if you are within the cell you can communicate, and there are cells adjacent to each other, so there are multiple cells, so there will be multiple towers, and so on and so forth. And while you connect through your mobile to this antenna, and from there it goes all over to other end, and finally it gets delivered. If your friend is also, and you're communicating with somebody, okay, then it gets delivered to that antenna, and from there it goes over wireless. In case you're doing say WhatsApp to other end, to a person who is also on WhatsApp on mobile, okay, that's one kind of, so cellular communication, there's one kind of communication. Okay, and then you have for example, you have a home network. Like at your home you are connected to a router, okay, and this router is may in turn be connected to a Wi-Fi router. Now both things may be built into one machine for you, so you may not see the difference. Okay, so there's a Wi-Fi, we call both of these together as Wi-Fi routers nowadays. Okay, so your machine can be connected to Wi-Fi router, or it could be connected over directly Ethernet. Okay, a wire that runs from their Wi-Fi router to your laptop. That's also possible, right? Or it could be an enterprise network or within organization network where you can have Wi-Fi. Nowadays, most of the LAN works over Wi-Fi. Wi-Fi lines are there, but also you will see that Ethernet also runs. Okay, these are called access networks through which you connect to core routers or local or regional ISPs, or we call it access ISPs. Yesterday we studied about it, right? Okay, all right. So there are what technologies we use to connect your Wi-Fi router to access router, right? Or router here, for example, this place. Yeah, this is your home network. This to this, what could be this technology? Okay, so it could be DSL, cable, fiber to home, or wireless. DSL is your, if you are old PSTN phone, and then a wire comes, twisted shielded pair, some kind of wire comes, and use that wire for both data communication or internet communication and also for telephone. This used to be technology about 10 years back, and some parts of the world still people are using DSL. Okay, digital subscriber loop. Okay, okay, cable is your TV cable comes to home from Airtel or Jio or whatever, and then part of that bandwidth can be used for internet. And nowadays, most of us are using fiber to home. This was expensive technology earlier, but now directly fiber comes to the router, home router, right? Or it could be wireless. And your router is connected to access router through wireless technologies, right? Okay, like in a hilly area where wires can't go, then you can connect your home router to access router through some wireless technology, right? But DSL, of course, you can read it by yourself. Then this is cable-based network. So from head end, where the cable operator is, that cable runs, and at each home there is a splitter. Okay, and then you get channel for TV, and then one channel you use it for datacom or data communication. Okay, we'll skip that. Wireless access network, please read it. And most popular nowadays is fiber to home. Directly fiber comes to home, right? So this is internet, this is central office, or like Airtel's office or whatever. Okay, and then there is a optical cable runs, then this optical cable is splitter, and this will send frequency to your home corresponding to your connection. Okay, and there is something called ONT, which is called optical. ONT is what? Optical network terminator. This will terminate connection, and then from here you can connect your Wi-Fi router or router. And from Wi-Fi router you can connect various machines. Okay. So these were the technologies. Like at home nowadays, you have mostly fiber. Fiber comes here, and then you have router. Okay, router will have like terminator that's shown here, ONT, and ONT is connected to router. This is a router symbol. This is a router, and from that router you have Wi-Fi terminal connected, and then from Wi-Fi you can connect to laptop, or from here directly you can run Ethernet to connect your laptop, and so on. Okay, all right. So please go through it. I will ask you questions based on this. Okay, all right. Okay, and then you know all about data center or cloud network, and within the cloud network, networking is very different. Okay, it's not the ordinary LAN. Ordinary LAN is not very organized, right? But here, even the addressing and so on is quite different. So maybe sometimes you will learn about how data center for cloud is actually organized. Okay, all right. A little bit about packet switching and routing. Okay, what is the difference between switching and routing? Anybody? Anyone? Those who are in third year should know about it. Nobody knows about it? Aryan Raj, are you there?
Yes, sir.
Need not know everything. Okay, all right. So let's look at it. Switching, normally we use this word when we at layer 2, Ethernet level. Routing is basically how your IP packets finds route across the whole network from your machine to for example, a server, Netflix server, for example. It goes through multiple routers, but how does it find the path? And that's the routing of packet. Like for example, you travel, you don't know anything about route to, for example, Delhi. Okay, you don't know. I mean, you don't have Google Map. You don't know. You just know how to drive. Okay, then you take the global address, your address in Delhi, and at every router or every traffic police guy who's on the way, show your global route, global address, and then your Delhi address, and then he'll say, okay, there are 4 lanes that are going out, paths going out, you go into a particular path. Now you do this thing at each signal you get until you reach destination, and assuming that each traffic police guy knows where to send you to, that's called routing. Now how does this all traffic police guys or traffic guys, police guys know about the route? That's done through routing algorithm that runs in parallel, that gives input to all these traffic guys that okay, somebody comes to Delhi, this is the shortest path. Okay, the dynamically these traffic police guys are informed about a path to Delhi or somewhere else. Now, for example, somebody wants to go to Agra, then the path goes through Delhi. The traffic police guy will know this is the route. And what happens in the way, for example, on the way the path is, for example, through Chandigarh, and you find the road to Chandigarh is all blocked. Then this traffic police guy should know somehow that now I have to change the route to some other route. Okay, this is called routing, and this exactly IP packets work, that each router on the way must know where to send the packet to. Okay, all right. So now we have access network we have studied. From access network we get into global ISPs. Okay, and then these global ISP are interconnected. We call this network core. It's a mesh of interconnected routers. So what happens is that when you are running an application, that creates, application layer creates packets with the bits. It fills bits in the packet, and that packet travels from node to another node. Okay, so it's like this. Now let's assume that this is where the core of the network is. Okay, okay, so now this is first router where your packet will come. Okay, this packet is coming here, right? Now it will have a destination address. Now we have shown only 4 bits. It is 32 bits actually. Okay, now looking at this global address, based on the knowledge this router has, it will select out of 1, 2, 3 outgoing links. Okay, so it means that it must have some information like this. So it says that if header value is say 0100, that's destination address is 0100, then go to output link 3. If it is 101, go to output link 2, or if it's a 0111, go to output link, okay, 2 is 1001, then go to output link 1. Okay, something like this. So traffic policeman knows now, when you are traveling from Mandi to Delhi, a traffic policeman at Mandi will know when you show address to Delhi, you will say there are 4 outgoing roads. It will say don't go towards, for example, Manali, just go towards some Haripur or whatever in between comes up. Okay, so it will tell here that just go to this road. Now when you are driving, you don't know anything. Now you need to go to the next traffic police guy and ask him, my global address is this 0111, please, where should I go? Then he will say, okay, go this way, and so on and so forth, right? Now what this decision by this router or traffic police guy is taken based on some information, some table it has, this kind of table it has. Okay, so this local action is called switching. When you go to police guy, the police guy looks at your address and sends you to one of the roads. That's very local action. Okay, police guy just knows only about very limited things. Okay, that's called switching. Okay, so it's nothing but from input link to one of the output link. That selection is called switching. But how do all these traffic police guy on the way have this table filled up? Because if every guy has a table like this, right, based on address which output link one can go, if this table is set, then whatever person is going or packet is going, it will reach to destination. But this table filling process for various addresses, okay, is called routing. Okay, so this helps packet to route or go from one node to another node until it reaches to a destination. That's called routing. All right. Okay.
Sir, what if we don't have an entry in the routing table for a destination?
Then you can't.
Okay.
It's important, right? Otherwise, how will you route the packet? This is the work of, there is a protocol called OSPF, BGP, and ISI. These are the three protocols that one of the three are used for, of course, for different. Mostly we use, say, OSPF or BGP when we go to, say, Airtel to, so higher level network. Okay, so this table filling is the job of these routing protocols. How does it do it? Then there is a whole algorithm for that. This is all where routing algorithms come into play, and it's all distributed algorithm. There is no central guy telling, okay, this is how it does not say. There's no central guy here will say, all right, from if somebody is coming from Mandi to Delhi, this should be entry. There's nothing like that. So this network, these routers have to learn continuously and update themselves. So this is a routing algorithm. It's very important routing algorithm. Please try to learn that if you want. And then the question is that, can there be security hole in these routing protocols? Yes, because it's all distributed. There's no central entity here. Okay, it's based on net nodes telling that, okay, if you send me packet, then the cost is this much. Okay, for example, some from Mandi to Delhi, packet has to go. If router that is at next station, I don't know, say for example, Chandigarh says that you can send packet to Delhi, the cost is 5. Okay, there may be another router which is at Manali says that if you send it through me, cost is 6. And like that, based on all that, local routers take a decision. Okay, so there can be a ROG router in between, and this happened in China. So now note that distributed computing based or internet based largely on trust. Okay, and if the trust is broken, then there can be a lot of problems. Okay, so there was a router in China, a ROG router. When it has always advertised route with minimal cost. So for few minutes, the whole world's traffic came to China, and they could do whatever they wanted to do. So please read about it from internet. Okay, all right. Now note that packet switching is always store and forward. Like when your mother sends you a box of sweets, it does not, the courier guy won't say that every time it's on transit, it's running or it's going on vehicle or whatever. So from your mother's place, your home, packet comes to courier office, right, or PSTN office. There it will stay for some time, maybe a day or few hours, and until the next route, for example, is going to Delhi, it becomes free, and on that it can be sent. Similarly, IP packet, when they come to router, and each router has a limited space, right? Like in traffic signal, you wait until signal becomes green, and if there is a lot of traffic, then this queue becomes very long. Okay, now here the packets travel over link, and there can be many packets on the link at a time, one after the other, and this router stores them and then looks at the header, and then destination address send it to appropriate route. is called store and forward. Okay, all right. But there can be queuing because there can be a lot of traffic and router has a limited capacity. Like your traffic signal has limited capacity, so there will be queuing, right? And that queuing causes delay. Because this switch is going to service packets and there is outgoing link and already there is a packet that's being transmitted, your packet has to wait. Queuing happens everywhere in the world. It's very real time, real life phenomena where the arrival rate is faster than that can be serviced. Okay, all right. So this queuing delay adds up to overall delay. Okay. Now look at this. Now here there packet is coming from source 1, so then source 2, and this is a router. Okay, now these are the packets that are coming here. Do you think there will be congestion here or queuing delay? No, this packet will get routed here if this outgoing link. Then this packet will come, then this packet will come, and so on and so forth, right? So now they will go. There is no queuing delay. Okay, now would there be queuing delay? Yes, there are two packets arriving at the same time. So one of the packets have got to put into a buffer. So switches a buffer. Okay. Okay. So this is the buffer or where the queue is formed. One or two packets, for example, just a minute. Yeah. Okay. So just before that there was some so now one of the two packets, these two packets are coming. One can be transmitted here, right? So one of the packets will go here. All right, now again there are two packets which are to be serviced. So one of the packets will go to this queue. Now this packet has gone to this queue. Now there is no packet here in any incoming link. So these two packets can be serviced, so they will go out and so on, right? This is how it happens on the internet. Any question? All right. So now internet is based on layered model. Okay. So now you would have studied or would have looked at it, this 7-layer OSI model that came about 30 years back. Initially, when networking was beginning, people thought 7-layer model is important. It's called OSI 7-layer model. But for internet, they say we don't need 2 layers. This session layer and presentation layers are not needed. So they reduce this to only 4-layer model. Actually, this can be treated as a 1 layer, and these are the 3 layers: network layer, transport layer, and application layer. Okay, usually it's called 4-layer model, or you can call it 5-layer model. Now, what is the layer? What is a layer? What does it do? Why do we need layering? So note that the world that is presented to you is very simple. For example, in mobile, your grandmother, assuming that she is 80 years old, can use it. Why? But if your grandmother is told that there is a processor which is based on, say, some technology, RISC technology, it is quad-core processor. Okay, it has 16 registers, and data moves from register to processor, and then there is a RAM which is 1 GB, and then you will have to create a you have to create a packet, and this packet will go to your device driver. From there it will go to the OS. From there it go to somewhere, and finally go out. She will say, what the hell it is? Okay, even now our laptops and desktops are not, the UI is very, very weak. mobile guys did better job. Okay, so now what all this complexity of the world is hidden behind abstraction. The interface presented to your mother, for example, for WhatsApp, is just simple, press a button. But inside there are hundreds of processes that will fork. That's all hidden. Similarly, in networking, so in OS, we find that it's all hidden. Complexity is hidden between different layers, and some of that we have studied. For example, here, you have voltage levels, device drivers, system calls, runtime library, code. When you write a code, you don't care whether it states process or what libraries it use. You don't care. You just write a program and automatically use a runtime libraries. Okay. Similarly, in internet world, we have these layers. Okay, and it provides abstraction to higher layer. When your app writes, when you write an app, you simply use the interfaces provided to you. You either use sockets or application APIs. Okay, and using that APIs, how these APIs is implemented, whether these APIs using TCP or UDP. Okay, and whether it is going over Ethernet or Sonnet or whatever or cable, you don't care. Okay, so each layer above provides abstraction to higher layer, and lower layer provides service to higher layer. So when you write application, you use transport layer APIs, which in turn will use network layer APIs and so on, and add some functionality and present it to higher layers. Okay, all right. So each layer has a protocol. It relies on service provided by layer below it, and so basically application relies on services provided by transport. It uses transport layer APIs. Okay, all right, or interfaces, well-defined interfaces. Okay, and it provides service to below, right? So, and it okay, it provides service to above, and the higher level uses or delay uses functionality provided by lower layer. Okay, all right. So simple. So we have already seen OS. So let's look at this very simple example. Alice is the CEO of a company, and Bob is her friend, and he is also CEO of a company or manager or whatever. Okay, Alice wants to go for lunch to a restaurant along with Bob. So she wants to send a message, I am hungry. Okay, what she will do, I mean, she is very senior level. She doesn't have time to make a call or whatever to Bob, right? She just calls, sends a message to her secretary, tell Bob, inform Bob that I'm hungry. Okay, and he knows the Bob's address, etc., right? What will he do? He will send this message over mail to 123 Bob Street. This is 123 Bob Street office. Okay, so this information is put inside another information. The secretary doesn't know that she's sending a message, I am hungry. Okay, all he does is that whatever he receives, he put this another envelope or whatever, and then says that mail it to 123 Bob Street. Okay, so I will repeat. So Alice has message that I am hungry. She puts this in an envelope and then says send it to Bob. This guy receives it and puts this thing in another envelope and says that writes the address 123 Bob Street. Okay, now this travels to other end. Okay, this guy here, this office receives it, then sends it to secretary here. Okay, he will receive this. He doesn't know what's inside. All he knows is that it's the message for Bob and delivers that envelope to Bob. So there's a communication happening here between Alice and Bob, which relies on sending message to this guy, and this guy depends on this communication, this mail service between the two. But we can see this as an end-to-end communication, right? When your machine is communicating on Netflix router, Netflix server, you don't care what is happening in between, whether if data is going downwards and going to some other machine and so on. Finally, all you see is a direct channel between your machine, and Netflix server. Okay, so each layer communicates with each other relying on the abstraction below them. Okay, all right. So now on internet, we have a model, layered model, which will look something like this. Applications are built on reliable or unreliable transport. Many applications we run does not require reliability. Okay, often video communication doesn't require so much of reliability. It means some packets can be lost. Okay, and that is built on global best effort global packet delivery. Now note that internet does not promise that your packets will reach properly, right? Okay, so this is best effort global packet delivery, which is based on best effort local packet delivery. What does it mean? When your mother sends laddu packet to you, the courier guy will not guarantee that it will reach properly to other end. If it's a lost, if you have not received it, you will inform your mother, I have not received it. She will make another box of laddus and send it to you. And in between, local courier guys from your mother's place to some courier center, that's called local delivery. From your laddu packet will travel from one courier guy to another courier, one center to another center. Here is your mother. She hands over a packet. This guy will send it over cycle to other center. Now this guy on the way will wrap it up the way he or she wants and try to deliver it here. This is the local delivery. Once the packet received here, laddu packet received here, okay, that will put into another box. Okay, and that box will address of this next courier guy, next courier center. Okay, and then when this guy receives this bigger box containing your mother's box, will remove the top box and look at the address and take the box out, put it in another packet, big packet with address of this guy, and so on and so forth. So your packet depends on best effort delivery in the local network. Why? And this is how the global routing is done. Now note that the best effort means that local guy who's carrying this box of sweets can drop it. There's no guarantee. Internet does not give any guarantee that packets will never be lost. Packet can be lost. So what will happen? If you are running application end to end and your packet is lost, now you would have stored the packet somewhere and you don't get acceptance or acknowledgement from server, then you resend it. That's how TCP works, right? Like your mother, if you didn't receive sweet packet within the next 3-4 days, you'll call mother, possibly it's lost. I have not received it. You'll say, okay, I'm sending another. Now for your mother, it's very difficult task to make another 1 kg of laddu, but for machine, the packets are already there, right, with the contents, because your machine, until gets acknowledgement, will not drop the packet, will not throw away the packet. All right, so retransmission is easy. All right, so this is the model that we have, internet model. Now we can look at this model. So we have applications, okay, that is built on TCP UDP, which provide reliable communication service globally or unreliable service globally. Okay, that is based on IP, which defines IP packet format and routing of packets. Normally routing we don't mention much, but routing is also part of this. And below this could be any kind of technology, layer 2 technology. In the local link, when your mother sends a packet, and packet, assume this IP packet. Okay. Now how does it go over cycle or truck or by air flight? It doesn't matter. As long as this IP packet, laddu packet, goes to one node to another node, and in between, of course, this node, the cycle guy will put this sweet box into another box such that easy to carry according to the protocol. Okay, and so on and so forth. So at each local link, each link packet is your mother's packet is taken out, globalized is seen, again put into another packet, and that packet will have address of the next node on the way. And that's how it travels. And all these technologies are nothing but these links that are in between. Okay, all right. Good. So this model we can view this. IP is called narrowest, common in internet. Okay. Every machine that will be on internet must have IP and also TCP and UDP, because some use TCP, some use UDP. Okay, but underneath here could be any technology that supports IP packet transmission. Okay, and application protocols could be anything depending on what two entities at the end want. Okay, all right. So this is narrow waist model that you should remember. Okay. Give me a minute. Wow. Just a minute. Get this new iPad is yet to. Just a minute. Well, let me just switch. Okay. Give me. Okay. The only thing is I will not be able to use span. So now internet, we have this model wherein on left you can see multiple layers. The host uses all 5 layers, while routers use only 3 layers. Okay. All right, so this is host, this is server, another host, and router in between uses only up to routing layer. Now transport, which is TCP and UDP, will run only at the end applications, end side, because if application requires reliability, then TCP will be run, otherwise UDP can run. Okay. So this is another model. So routers contain only 3 layers here. We can see Ethernet layer in, let's assume that layer 2 is Ethernet. Layer 1 could be copper or whatever. Okay, and IP is used for routing. And then Ethernet could be, instead of Ethernet, you can have Sonnet or some other layer 2 technologies, right? We have seen for various links, there are different technologies that can be used. Okay. Now we can see that as packet goes from higher level to lower layer, it gets encapsulated. Okay, all right. So this is a So for example, higher layer is TCP header, a TCP packet, and inside that is application packet, right? HTTP. When it comes to TCP layer will put its own header, and this hands over this to IP layer, and so IP layer puts another envelope on top of that and puts own header. For IP layer, this whole TCP packet becomes a payload. For TCP packet, HTTP request becomes a payload, and so on and so forth, right? Okay, all right. Then we can see how packet travels inside a network. Here it's like this, right? Your packet is being sent from your machine here to server, and then server responds back. Like, all right. Now this is called uplink. From your machine to server is uplink, and this is called downlink. Normally traffic is more on downlink, but this is what you visualize. You know, this is what you visualize, right? This is a virtual way of looking at it. Okay, you don't see that there is in between, there is a lot of routers in between, and in fact your packet is going to multiple of these routers. Okay, so for example, this is your program, this is a server. Just a minute, huh? Just give me a minute. Okay, sorry. There's somebody at the door. Okay, all right. So your program sends packets and response. Some other machine sends multiple packets. Okay, but your packet travels over set of routers like this. Okay, so when you're sending it from machine to Wi-Fi router, it goes first to Wi-Fi router, then travels to end. Okay, for example, if you have this image, then this image, data corresponding to this image goes into packet. So this image will take multiple packets to reach to other end. So this is a packet, something like this. Part of image comes here, it goes into a packet, destination address is written. Okay, and from address, your IP address, destination IP address is given to router, and routers travel this over local link to the destination, and then this is how the whole image goes to other end. Okay, just another 2 minutes will close, and it's all best effort delivery, right? For example, internet does not say your packets will reach to other end, so in between this is your packet can be lost because there may be any reason, you know, there may be a lot of congestion and the packet may be dropped. Okay, or here it may get garbled. For example, here is getting garbled. Okay, or the packet may be duplicate and reach out of this packet, first packet and second packet. The second packet may reach before the first packet. Okay, or duplicate can happen, same packet can be duplicated, or the packet may get lost because buffer may be full. All right, so let's stop here. In the next class we'll start from here, and then we will continue, huh?